So what is your quote or the answer or the comment about the quote that says, brain doesn't feel pain, but we need brain to have pain?
Yeah, I say it's a tautology.
A what?
Tautology. A tautology in logic is a sentence that is always true and cannot be proven wrong. So I don't see it as a useful sentence. Like I cannot like refute it. I cannot like you cannot find an animal without a brain, or you cannot talk to other animals besides humans. So how are you going to prove? So like I don't know. It's not a helpful sentence. Like,
well, yeah, it's like, you know, some quotes that are there to be smart kind of expressions probably, but in the end of the day, you know,
it's an unhelpful sentence. A tautology is just like an unhelpful answer. It's like, what am I going to do with it? It's like it's always true. Okay. I cannot prove it right. I cannot prove it wrong.
Yes.
So I really don't see it, but like it turned into a slogan of like pain science.
It's
like,
probably like a slogan, yeah.
Like a slogan, but when you think about it logically, it doesn't make any sense. Like it's like, okay.
Yeah. So let's talk about the descending inhibitory nociceptive mechanisms. For example, when you have a person who does Krav Maga or does boxing or karate, whatever, okay, and he gets a lot of nociceptive stimulus because he gets a lot of punches. There is a nociception, okay?
Yeah, there is nociception. Okay,
yes.
Yeah,
but probably it's what you said before. The descending mechanism of his says, not now, you are to survive, so don't feel pain now.
Or like it's like Krav Maga and the practices themselves are not associated with threat. So like again, eventually it's just descending inhibition, and probably also some other mechanism that, like, it's a hypothesized mechanism, and there is some evidence to it that like some free nerve endings die, and you know, and you become numb, like to getting hit. For example, what the Thai boxers do, they take like a stick and they rub it on their shin bones.
Yes.
Rub it on the shin bones for doing low kicks and stuff like that. So it's also speculated that like also they have less that it kills some of the free nerve endings and they become less sensitive. But then again, eventually what they do is just like they have very good responsive descending pathways, descending inhibitory pathways, like people, and you can train it. But then again, it's only for a short term, like, yeah, it's good for getting kicked or being in a battle and stuff like that. But at the end of the day, someone who gets hit really hard and he doesn't feel it right away, or he, like those people who break bricks, maybe they don't feel it right away, but when they go home, they start feeling it some hours later. And I've asked a lot of people who do that, and they told me, yeah, sometimes like a few hours later, I will start feeling it. So.
So I have another question for you. There is a quote that says, nociception is necessary, but not always sufficient to experience pain, or at least pain that makes the person go and seek for help. So that's the clinical relevant pain.
Yeah, I think you meant to say that nociception is neither necessary nor sufficient for pain, which I have no idea where this sentence came from. It's totally wrong.
It is?
Yeah, totally, like logically and evidentially. Again, I think it came to be because of misconceptions and problem with the definitions. Because a nociception is defined as the process of encoding a noxious stimulus. Mm-hmm. Okay? So if you defined it as like nociception as the process that requires and must have a noxious stimulus, then you can say, yeah, well, pain is neither necessary nor sufficient. But, but we know today that nociception can happen without a noxious stimuli, like via epigenetic molecular activation. Now, you can start thinking whether molecular signaling is a stimuli, and I tend to think that it is a stimuli. It is just not a stimuli that we can see, or we cannot see it like heat, like, or feel it like we can. When I prick you with a pen, you can see the stimuli. When I put ice on you, you can see the stimuli, and you can attach it. But when we're talking molecular, microscopic level, it's not something we can see, or not. Also, it's very difficult to test for it. Yeah. But I believe in the future we will have tests for molecular signaling in pain states. So if you realize that, then you realize that you cannot have pain without nociception.
Well, the notion is that nociception is necessary.
It's necessary.
It is, but not always sufficient to experience pain.
Yeah, like we talked about, like those people like in Krav Maga or karate and stuff like that. Nociception is happening. It's just not. It's just being inhibited.
Yeah.
By those descending pathways. And once those descending pathways stop, then you can start having the conscious experience of pain. But pain, absolutely, for us to have the experience we call pain, we need nociception. There is no other biological substrate. Yeah.
And do you think that we can say, for example, we can topographically not isolate, but say, for example, you can have nociception, blockage of the nociception input in the spinal cord level or at brain level?
When it comes to the nociceptive apparatus, you don't really have central or peripheral, or I see it as unhelpful to think about it in a central and peripheral way. Hypothetically, there could be pain states that are more maintained by brain-related mechanisms, but then again, like not psychological. I'm talking about actual hormonal, glandular, and immuno mechanisms, okay, in the brain. It's not like people tend to think like, cognitive, processes and stuff. No, these are like, I don't know if people are aware of it, but we have an immune system within our brain, a specialized immune system, the astrocytes and the glial cells. It's the immune system of the brain. And we have evidence for dysfunctional immune responses in the brain, in fibromyalgia, also in chronic low back pain. There's a great study that came out this year that found abnormal activation of glial cells in the brains of people with low back pain.
Which is irreversible, probably, isn't it? Is it? It can be reversed, can it be changed?
What, a chronic non-specific low back pain?
Yes, this mechanism in the central nervous system with the glial cells.
I don't think it's simple.
I believe that too.
No, it's not simple. It's not simple. And again, some people have a tendency for having this dysfunction. They're just genetically predisposed to that. It's a very persistent problem. Some people can have back pain like their whole life.
Yeah,
it's very unfortunate, but again, it's a fascinating study, by the way. Like that study that came out this year. Like I don't remember its name, but what they did is they did a PET CT scan with a specialized radio ligand called PET TSPO. Okay. It tests, like it marks, it radioactively marks what's called a translocator protein, which is a good indicator of glial activation. And they just saw this, like they compared like brains of people with non-specific low back pain and brains of people without any back pain, and like it was pretty apparent that this abnormal immune activation is ongoing in those people. So hypothetically, yes, but then again, I suspect that they haven't tested the spinal cords of those people, and we also have glial cells and astrocytes in the spinal cord. So I hypothesize that we will also see this in the spinal cord.
So in this way, what I understand from people who speak about central and peripheral mechanisms, I have it in my mind like a peripheral, let's say, stimulation of the nociceptive apparatus is when you have an injury. So you break your leg, you twist your ankle, that is a peripheral input. Whereas when
but for example, the central sensitization, the process of central sensitization always starts peripherally and always ends up centrally in the spinal cord. That is the physiological process. And central sensitization, as was described by Wolf in his known paper from 1983, it's a physiological process that includes, it starts at the periphery and it ends in the spinal cord, always.
Yeah.
So that's why I say it's unhelpful to divide it into peripheral and central, because eventually nociception is a whole organism response. Okay, it's to reduce it to like peripheral and central is like it's too much of a reduction. It's a whole organism response, nociception. Okay?
Well, I think that in this way you just say the series or the sequence of events that occur in the periphery, and then they're transferred to the center, and then maintained by, let's say,
epigenetic processes, molecular processes. Yeah.
What do you think about the contribution of the role of the structural changes we see in MRIs and CT scans to pain experience? For example, patients come to me. When I ask them, what's your problem? What they do is the first thing that they tell me is I have a slip disc, and they just point me the MRI.
Yeah.
So this structural approach, which is, I think, maintained hardly by the medical profession, which is pretty much focused on that. So what do you think about the contribution of the structure model to the pain experience of people?
Yeah, well, the structural model was an important development in our medical understanding, but we now have to realize that we have transcended the structural model. Well, and I will say this, it's going to sound a bit, it's going to sound a bit strange. I would say there is no such thing as a non-specific low back pain, okay? Pain is always specific to the nervous system, okay? Okay, like, and this is-
You need the nervous system to have pain.
Yeah, but it's always specific to nociceptors, okay? Yep. It's always specific, and it can only happen in nociceptors. Our discs, they don't hurt. Our bones, they don't hurt. Our muscles, they don't hurt. The only thing that can do the hurting is the nerves or the nociceptors. It's the only thing.
Supplying the structures.
What?
The nerves that supply some of the structures.
Okay, so for example, and this here we get to a very important clinical aspect that people always ask me, oh, so what are the clinical implications of the stuff that you're talking about? Okay, so why do some people with like, you know, like you can have like someone with a really huge disc bulge, but have no symptoms.
Yeah.
Like have no leg pain at all, no irradiating pain. And you can have someone with a very small, small disc bulge and very bad irradiating pain. Yeah. Yeah. And the answer again is, what is the status of the inflammation? If there is inflammation, he will have symptoms. But if for some reason he has very good immune responses and very good genetics and epigenetic responses, then his inflammation will be controlled. Yeah. And then he won't get symptoms. But some people have, unfortunately, they have bad luck and they don't have a good set of responses, and they will get irradiating pain.
Yeah.
There is a lot of evidence for what I'm saying right now. So you can, like the stuff on, like even the structural findings, I used to think like they're not important, but I changed my mind lately, and I'm starting to think again that yes, they are important.
What is important?
Structural findings.
Okay.
On structural findings on MRIs, they are important. We cannot say that just because someone doesn't have pain and we take an MRI of his back and we see that he has disc bulges but he has no pain, does not mean it's not important. Okay.
Okay.
It can be important, and when it is important, we need to pay attention to those findings.
How do we diagnose when it is important? That's the question.
Yeah, that's a good question, and I think that in the future, again, with the advancement of technology and specialized, personalized drugs to control inflammation, we will be able to neutralize the inflammation, and then like you can have a disc bulge, and hey, it doesn't matter anymore because you don't have the inflammation, you don't have the pain. So and also again, like this also explain like the stuff that we talked about. It's an important also another important clinical aspect, because patients always ask that if it's an inflammation, then why did the anti-inflammatory drugs did not help me? Now, those anti-inflammatory drugs are crude and they're not specialized. We all have different enzymatic profiles. Yeah. And in the future, we will be able to personalize those enzymatic profiles to the person. And today we have it's like the difference between a guided missile and like a dirty bomb, you know, like a napalm bomb. Like those medications are just like napalm bombs. You just drop it, just burns everything. Okay, but it's not specific and it's not targeted. That's why they don't help a lot of people. But eventually, I tend to think that if there is something that is very specific to pain, is inflammation.
Okay.
Now, and this is another important aspect, inflammation is not one thing. It's not like one response. We now know that inflammation is a spectrum, okay? It's not like people tend to think, like healthcare practitioners tend to think, oh, the inflammation is good for you because it heals you and stuff like that. But that's not true, because we now know that inflammation can also kill you. Okay, for example, during the corona, people started hearing about what we call a cytokine storm. Now, what is a cytokine storm? It's a very bad inflammatory response by the immune system, which ends up killing the person. That's not good, right? You agree with me? Yeah. If the person dies, that's not good. No. So it's a spectrum, and it can heal you and it can kill you.
Yeah, it can be part of the normal process of repairing, but if it goes out of control, can make problems like the autoimmune diseases.
And we now know that there are millions of variations of abnormal immune responses. Millions of variations that you can like. It's almost like unfathomable. It's hard to grasp it. Like the amount of combinations of immune responses that you can have. It's a very complicated area. But again, I think that with the advancement of, again, machine learning, artificial intelligence, advancement of basic sciences, we're going to be able to catch up with those processes and understand how to control them. But right now, it's a very big problem. So whenever someone is complaining about like symptoms of pain is always very specific to an inflammation. And we are also not very good at testing it. Like in the blood, we know how to look for certain markers of inflammation, but we are discovering new markers all the time. And there are, again, thousands of possible markers of inflammation that we are learning to identify. We will be able to identify eventually most of them, I believe. Yeah.
So what you say is that when we have pain, this means stimulation or activation of the nociceptive apparatus plus coexisting inflammation in all states.
An abnormal inflammatory process, yeah. Again, which is dictated molecularly through epigenetic, abnormal epigenetic responses and stuff like that. Yeah, that's what.
And this inflammation is like what we used to say peripheral sensitization of the nerve endings, like peripheral.
Yeah, it's a part. It's the same processes, but then again, they become maladaptive or aberrant or pathological. They just keep on going for some reason. Like again, I don't think that we will be able to understand the reasons for that, but we will be able to treat it when we see it. To understand the reasons why I don't think that we will be able to ever truly know why it started. Why it's genetics, it's bad luck.
And probably this is the reason what they say or what they mean when they say non-specific low back pain is because they don't know any apparent reason. I did not lift something up.
No, the term non-specific comes from our lack of ability to ascribe it to any known structure.
Yeah,
but that's not true, because we know how to ascribe it to the nerves themselves, to nociceptors. So it is specific to nociceptors.
When you can understand your point.
Okay.
So what do you think about the next one? So we have inputs arriving at the brain. So we have inputs that stimulate our five senses. Okay.
We have a lot more than five senses. We have like we have some people. Some divisions divided into like even 16 senses. Okay, yeah.
And let's say that the notion is like that, or the quote is that every input of the brain creates an output. So I smell a food. I remember when I was with my grandmother's house, and this gives me a feeling of being homesick or whatever. I remember a smell of a perfume which reminds me of my first love. Whatever, and then when I have a noxious stimulus, the output is the muscle spasm. So the idea or the theory like that is
okay. Yeah, I see what you mean. Like again, the nociceptive system is built from afferents and efferents. Okay. So again, and people tend to confuse this also, like, oh, the pain is causing me muscle spasm. No, it's the nociceptive activation that creates the muscle spasm, because, like, you know, for example, a reflex arc is afferent and efferent. Okay, so again, this is a nociceptive process. Okay, so I would distinct that from pain. Pain does not cause anything. Pain is merely our conscious recognition of those biological processes that are occurring in our body. By itself, it does not do anything, okay?
Only pain.
Okay, and we wrote a paper about it now, like how pain is not like some sort of agent that can actually cause anything. It's not like this is a conflation, confusing between the nociception and pain. The process of nociception can activate efferents and create muscle spasms and stuff like that. Okay.
So you mean that the noxious stimulus gives, results in a brain response called muscle spasm?
No, muscle spasm is a spinal cord reflex arc. Okay, it happens on the spinal cord, so it cannot happen from like a perception of pain or whatever people may want to call it, because again, it's a spinal cord loop of afferent and efferent. The efferent descending pathways are able to inhibit like inhibit the upcoming of the incoming noxious the incoming nociceptive signals. Okay.
Mm-hmm. So what you mean is that what we call protective mechanism of muscle spasm
is nociception. These are nociceptive circuits. It's not pain that activates those things. No, like our protective apparatus is the nociceptive apparatus. Anything protective is related to that, not to pain. Pain is like the higher conscious recognition of this activation of this apparatus.
Okay, but when you have a patient, we have a person, okay, who has this noxious stimulus, which is stimulus of nociceptive apparatus, right?
Yeah.
If the patient does not have the experience of pain, he will probably not result in muscle spasm. Isn't it like that?
No, you can have muscle spasms without any pain.
You can't.
You can have.
You can.
Yeah. You can have, sure.
In
like,
terms of what? Like clinical example, let's say.
You can see some people like even after their back pain passed, they still stand listed.
Yeah.
But they have no pain, but they're still, standing like that. It can happen, or you sometimes, like you look at people, like you look at their back and you see like this bundle of muscles, like contracted. You can actually see it, and when you touch it, it's like very stiff.
Hard, yes.
There's some sort of like sometimes there is a protective response over there, like a reflex arc with a muscle spasm, but it doesn't necessarily have to hurt.
Is it like a short circuit in a spinal cord level that it keeps that on going?
Could be, but then again, like if the person doesn't care about it, then
right,
we shouldn't care about it.
Okay, but in the beginning of when you have a person who is healthy and then suddenly he gets pain and then he goes to muscle spasm, is not the pain is the pain is not involved in the whole process to stimulate it, and then how it is maintained, it's another discussion probably.
Yeah, it's another discussion. Again, the pain itself does not do anything. All the stuff that we're talking about, this is all nociceptive stuff. It's right. The nociception itself, okay? That's why I say we can have nociception without having pain. We can have activated reflex arcs without us being aware of that, okay? Because for some reason, and again, we don't have all the answers. Why does it happen? Because in some people it can happen and we don't know why. But then again, people come to us when they are aware of the activation and they suffer, and this is the experience that we call pain. Okay, they come because they suffer. So yeah,
what I didn't quite understand, maybe I lost you somewhere, is that in order for somebody to have this what we call transition from the normal muscle behavior, what's normal for everyone is different, but going to a state that he has the protective muscle spasm, this happened because he felt pain.
Not necessarily. Again, like and the problem with the real problem of pain is related to what we call the hard problem of consciousness. Okay, have you heard about this concept? Pain is a conscious experience.
Yes, I heard about that.
Okay, and we have no idea how the brain creates our experiences. Now, what is an experience? First, we have to talk about what is an experience. If we define pain as an experience, then what is it? And the answer is a bit complicated, but not that hard to understand. Like right now, you experience me talking to you.
Yes. Okay.
Now, what is experiencing that? Who is you? Who is experiencing that? You. But then again, who is this you that I'm talking to? Okay. Now, we are sentient, conscious beings, and we are able to cogitate, and we are able to express our awareness to others. And here we have to introduce the concept of mind. Okay, what is the mind? The mind is this three-dimensional film, or even multi-dimensional film that the stream of consciousness that is coming to us, like the smells that we smell, the hears, like the sounds that we hear, the sensations. It's a multi-dimensional movie that are, some would call it, like, again, people say brain, but then again, like, no one has found where in our brain is this conscious self residing. Okay, and what creates this ability that we have as humans to experience that. Now, what is an experience? An experience is anything that your mind perceives. Okay, anything, like, for example, like, and it comes with a very basic sense of you being you. Okay. Okay, like, for example, I am not you and you are not me, and I will never be able to know how it is to experience what you experience. And we have no, also, like, when you start thinking about it, we have another problem it's a huge problem in the neurosciences, and it's a big problem for pain research, is that we can only agree on words. Okay, and what I mean we can only agree on words is that there is no way for me to know if, when I put ice on you, for example, I put an ice cube on your hand, I don't know if what you're experiencing is the same that I experience when I put a cube of ice on my hand. Maybe what you experience is my experience of being burnt by fire, and what you experience is like my experience of, do you understand what I'm saying?
I totally understand.
Like, when I poke you with a knife, maybe your feeling of poking with a knife is the feeling I get when I'm getting burned by fire. And maybe it's this problem, incoherence, the incoherent problem is called qualia in neuroscience. Okay, there is no way to prove that the way I see the color red is exactly the way you see color red.
Well, this is a problem in marriages too. In marriages, husband and wife.
Exactly, like, it's the problem of subjectivity. Like, there's no way to know that the way again, like, think about it, the color red. Can you prove me that the way I see color red is exactly the way you see the color red? No, maybe I
don't know how you see it.
Okay, you remember the dress like the dress that was on the internet in 2017 or something like that, when people said, "Oh, the dress is blue, the dress is gold, the dress is white." Again, because we can only agree on words. We can agree that when I take a knife, I can agree that the sensation that you are about to experience is of poking, is of stabbing. But what the quality of the sensation, I cannot know whether the quality is similar to my quality of sensation. And again, pain is a conscious experience, and it's like we're talking about something that we can only agree upon a word. But then again, like, we have a good ground. That's why I say that we should not confuse nociception and pain. Pain is the quality of is the quality that is associated with nociception. It is not the same as saying pain is nociception or nociception. It's not the same. It's different. Pain is a quality that is inherent to into each and one of us. The way I experience pain will never be the way you experience pain.
Exactly.
For you, like, you can have like a headache that if I will, like, you can maybe endure a headache that for me, like, if I endure it, like, if I will experience it, I will think I need to go to the hospital. Maybe you will get shot with a bullet and you'll say, "Oh, it's not that bad. I thought like getting shot with a bullet, would be a lot harder." And like, someone gets scratched and it feels like for him, the quality is equal to your bullet.
And it's also influenced by many factors, like the context, your culture.
Exactly. So we have no way to know. So we can only agree on words. We can only agree on words. And for example, like from even a neuroscientific point of view, there are no colors. We can only agree on wavelengths of light. Okay, it's just wavelengths. Like, we say this wavelength is red and this wavelength is blue. And we know that, for example, dogs only see those wavelengths and they don't see other wavelengths, and cats can see those wavelengths, but we don't know how they actually see, what the quality of their vision is. We have no way to know that. So this is the problem of consciousness. This is the hard problem of consciousness. We do not know why it's even necessary. Evolutionarily, and this is like the philosopher David Chalmers He's the one who came up with the hard problem of consciousness. And he's asking, why is it all necessary? Why do we need to be aware of anything? Like, look at cockroaches. They're not aware of anything, but they do pretty well. We don't need all these qualitative aspects of experience. We don't need it evolutionarily. It's totally unimportant. Also, to experience pain, like a lot of cockroaches, like insects, for example, they have just reflexes, and like they get along pretty good. Cockroaches are really resilient. They don't need pain.
Yeah.
So again, like, this is the hard problem of consciousness. Why do we need pain? We don't need it. That's why, like, people say pain is evolutionarily important. No, it's not true. Nociception is evolutionarily important. Pain, the experience, is totally unnecessary. On the contrary, I think it hinders us. I think it's like it's not. It doesn't help the organism.
Well, it protects you from being further structurally hurt or even die.
No, nociception does that pretty good. You don't need the conscious awareness of pain. You don't need it. And we wrote it in our latest paper. We wrote about it.
So what do you think about pain? Is it a market product?
I tend to think that pain, or basically consciousness, is what we call an epiphenomena. It's an epiphenomena. It's just like, it's there. It's not there for any reason. We don't need it. Like, creatures don't need pain. Creatures don't need consciousness. We don't need to be aware of colors. We don't need it. We don't need to have a personality at all. We can be robots. Why is it all necessary? It's not. It's just an epiphenomena.